Good afternoon, and thank you for joining us today for our webinar on achieving net zero energy goals in hospitals post-COVID-19, a discussion on how the healthcare industry can continue pushing for energy-efficient hospitals while still maintaining safe air quality to avoid the spread of diseases and viruses like COVID-19. A huge thank you to our sponsors, BranchPattern. Without them, these webinars would not be possible. BranchPattern is a building consultancy who believes that sustainability sits at the intersection of human experience and environmental stewardship. They make creating high-performing buildings feel less complex by offering integrated services in the fields of engineering and science. Throughout the firm's history, their purpose has been improving life through better built environments. This purpose influences all the work they do and the way they do it. A few housekeeping items. We will have a moderated discussion at the end of the presentation. Please utilize the chat feature at any time to make comments or ask questions. You can raise your hand, or you can also use the Q&A feature if you prefer to remain anonymous. By attending this webinar, participants may earn up to 1 ACHE qualified education hour and 1 AAA, one AAA Learning Unit Health, Safety, and Welfare. The slides will be shared on the Women in Healthcare website after today's presentation for all members. Wanted to mention that we would like to and remind you of our upcoming events: Black Perspectives in Healthcare on July 7th, Lunch with Leadership on July 23rd, and Equity and Health Disparities in August. We have a great panel to present today's webinar, and I want to thank each of them for their time. To get us started, let me introduce the moderator of today's webinar, Carrie Nakamoto, Commissioning Authority with BranchPattern. Carrie is a certified commissioning professional and certified commissioning agent with over 15 years of extensive hands-on experience in finding solutions for complex projects in the healthcare construction environment. Carrie articulates factors that are unique to the construction of healthcare facilities, implementing best practices, and providing buildings that promote health and wellness for their occupants. She has solidified herself as a valued industry leader, being rated consistently high by her peers and clients. And with that, Carrie, take it away.
Thanks, Stella. I'm really looking forward to moderating this accomplished group of people. Today's learning objectives include learning about various stages related to achieving low energy hospital design and understanding the industry's progress, challenges, and solutions in achieving high performance healthcare facilities. Our first panelist today is Rick Maniktala, president of BranchPattern. Rick has worked on more than 30 medical projects, and he is committed to advancing sustainability and promoting human and environmental well-being. He's well-versed in high-performance building programs and has been a part of many teams working on net zero facilities. After Rick, we have Heather Burpee, Research Associate Professor at the University of Washington's Integrated Design Lab. Through her work at University of Washington, Heather has established thorough research to increase efficiency and radically reduce energy consumption of hospitals while maintaining high-quality healing and work environments. Our final speaker today is Travis English, Chief Design Engineer for Kaiser Permanente's National Facilities Planning Group. Travis has spent more than 16 years in both design and construction administration of mechanical and energy power distribution systems for institutional, commercial, laboratories, and healthcare facilities. His professional experience encompasses renewable power systems, net zero building design, and building control systems. Each panelist will present a few slides, and then we will have a moderated Q&A session. So audience members can send questions through the chat feature or the Q&A feature. I do want to note that the Q&A feature is anonymous, but we will be taking questions from both chat and Q&A. So with that, we will start with Rick.
Thanks, Carrie. Hello, everyone. I'm really excited to be here and share Heather and Travis with you all. Necessity is the mother of invention, and net zero energy goals for 2030 and beyond are accelerating. They are necessary. My introduction to Travis and Heather became necessary earlier this year as this client that you see on the screen wanted to pursue net zero energy concepts for a new greenfield critical access hospital in the middle of Navajo Nation, border of New Mexico and Arizona. And as sustainability consultants, as Carrie mentioned, BranchPattern had designed high performance central plants, net zero energy schools, office buildings, visitor centers, but not net zero energy hospitals. So I needed to start by researching what was out there. Next slide. I came across this 2019 photovoltaic installation at Sutter Santa Rosa Hospital in California. And you can see there's a lot of photovoltaic there. What percent of the site, and by the way, I'm going to ask you to raise your hand, so find the raise your hand feature here in a second. What percentage of this site do you presume is covered by PV? Just put that in your head. How much more PV do you think they could fit on this site? There's some roof area, maybe some additional parking. When I looked at this is a hospital. It's, I think, a 96-bed hospital. I said, surely this is net zero. How many, by show of hands, think this is a net zero hospital? Okay, we got some hands coming up. I see it. People found the show of hands button there. So there's some, not many. And you're right, this isn't. If this were anything but a hospital, it probably would be net zero. So there's something going on here. So next slide. So when we look at what's going on, we see that hospitals consume more than twice as much energy as the next closest facility. And lodging facilities and hospitals are both occupied 24/7. So it's not just the number of hours per day that it's running and consuming energy. There's something else going on. This is the CBEX data that many of you out there might be familiar with. And we've made every other facility type net zero, but still hospitals are elusive at accomplishing those net zero goals. So I knew I needed some help. And so we go back to Navajo Nation. And this project, the assignment that sort of led me down this path is fast tracked. So they're actually taking a facility that was designed in 2015 and installed in Missouri and site adapting it to make up some schedule time. And so we have the utility data from that facility. And that facility was designed, not by us, by a different design team, to meet energy codes. And I was able to meet with the facility manager and folks there. And so designed to meet energy codes, baseline systems, 90.1 compliant. As you can see from this illustration, the energy use index of that facility built in 2015 is higher than the CPEX average. 282 is the EUI. And if we take the utility data in Arizona, Missouri's rates are much more favorable. It's gonna cost $7.18 per square foot. So if we simply site adapted these systems and didn't do something different, we'd need a lot of renewable. How much renewable? Well, I had our renewable energy team look at that. Next slide. And if we were trying to offset with renewable energy, we'd have to cover the entire site. So that's not doable. What we have to do instead is talk to people, experts like Heather, who you're about to hear from, and Travis to learn, really learning from Heather's Targeting 100 investigative research and Travis's practical experience and experiments at Kaiser, and apply some of that stuff to really reduce the energy consumption of this facility. So that's the journey we're on. And with that, I'll let Heather take it away.
Perfect. Thanks, Rick. So building on that, I thought I would do a little bit of a journey about thinking about a little bit more about what Rick talked about how hospitals use energy, what we know kind of in general, and then how we might crack that nut of decreasing energy significantly in the healthcare sector, and some thinking that I've done with lots of other collaborators to try to achieve lower energy in hospitals. Rick mentioned that healthcare has an outsized energy footprint, and this is just another way of saying that. This slide says that 5% of all energy in the US today, including all energy for industry, transportation, and buildings, is consumed by the healthcare sector. I've seen this percentage go up as high as 8%. You know, depending on how you calculate it, it changes. But the point is, that's really high for this one industry. To me, that's spells an opportunity, however. This is another way to look at it. Rick mentioned the database, the commercial, the CBEX database, and that's another way to look at how average buildings use energy. You know, the total building stock of hospitals in the US is less than 0.2%, yet they use 8% of all the energy. And that's just looking at the building sector. So again, an enormous opportunity. And the graph that Rick showed was comparing the typologies and looking at per square foot of energy use. We can also look at how do hospitals compare internationally. You know, are hospitals just going to use more energy no matter where they are, or are there examples of lower energy healthcare facilities? And what we see is, you know, we stack up on top, which in this case is not so good, right? We're using more energy per square foot than almost any other country in the world in hospitals. And so we can start looking at what are those hospitals in Germany or Scandinavia doing to get such a low energy footprint? So I've spent a lot of time thinking about that question. What can we do to reduce the energy footprint? And as a result of that, have been part of several development of roadmaps that I put here just to say these are great references for you to look at later. This is going to be a really short primer. One is Targeting 100, and Rick mentioned that. That's a research effort that I led and undertook through the University of Washington, my work with University of Washington, in collaboration with the Department of Energy and other collaborators. And the goal of that was to reduce energy to the point where we met the 2030 challenge at the time in healthcare, which ended up being an EUI of 100 in a hospital. So thus the title, Targeting 100. These other two guides, the ASHRAE AEDG, and that is a fantastic reference as well. And the one on the right, Travis and I have been collaborating on, thinking about how do we move towards net zero energy hospitals, and that'll be published by ASHRAE by the end of the year. So what did we learn as we've put together these roadmaps? I think one of the first things is thinking about the 80-20 approach. Thinking about, you know, 80% of the causes can be, 80% of the problem can be solved by looking at 20% of the problem. So think about another way of saying this is look at the low-hanging fruit first. I think it's a really good principle in a lot of things, including this. But how do we know what that low-hanging fruit is in a hospital? And, you know, another mantra that I like to talk about is you can't manage what you don't measure. So I like to base a lot of what I do in empirical data. And at the time that we started this work, you know, around 2007, we were looking at how do hospitals use energy? Let's start there. We did not know. And I don't mean just we as our research group, like we as an industry did not know how energy was being utilized inside of hospitals. We might have known the whole building EUI, but we certainly did not know what was causing the whole energy picture. And so we did a monitoring project where we looked at an operational hospital that was a really good design and looked at where are those energy sources going over the course of the year. And at this time, I would sit with design teams that were really smart people together thinking about what makes hospitals different. You know, why are they using so much energy? And we'd scratch our heads and think, well, maybe it's the medical imaging equipment because those use so much energy and they're different. That's why hospitals are different. And so after measuring the data and looking at a real hospital, we see that that medical imaging equipment uses about 1% of the total energy. That's still a big number because the whole magnitude of this pie is high, but it's not if we're looking at the 80-20 rule, it's not the first thing we would tackle. The first thing we would tackle is this big red wedge that's called reheat. Let's look at that first because that looks like a big area of opportunity. We're going to talk more about that as we go through this presentation, and Travis is going to circle back to that. But one of the main drivers of that reheat wedge is the air changes that happen in the hospital setting. So in all three of these guides, I'll say there's really a stepwise approach to cracking this nut of energy reduction. And it starts with load reduction. So this is something that I didn't fully appreciate when I started this work about what it means to actually reduce the load. So I do a lot of talking about EUI and the total energy that's used over the course of the year, but really we want to look at the loads that the heating and cooling plant are serving. And this is just a simplified graph of that to show that a baseline load might look like this. The area under the curve is the energy that's being used, but the peak, what that represents is the size of the equipment and the energy use. So when we think about size of equipment, we're talking about space and cost. If we can reduce that, we reduce the space and we reduce the cost. We also enable systems that are more energy efficient to be able to be used because they can manage that reduced peak load. So this is looking at the whole heating and cooling plant, but what we do is if we can get below a threshold with peak loads, we can then, the second strategy, decouple heating and cooling from ventilation air. Huge energy saver. If we think back to that big wedge, this is how we really reduce the reheat load, is serving the heating and cooling needs through water-based sources rather than air-based sources, and then delivering fresh air to the rooms. To do that, we must manage the loads on the exterior envelope. So in that way, the envelope is actually part of the mechanical system, and it's an integrated approach. So we're thinking about integrating architecture and engineering. They're really all one and the same. They have to work together. The third strategy then is, once you've managed the loads, decoupled the systems, is to have really good controls and turn down where possible. This is showing an operating room. Thinking about, we don't need to run the operating room as if there's a surgery happening 24/7. We can operate it when it's being used, but when it's not, turn it way down. And there are other spaces, for example, offices don't need to be run 24/7 like a hospital. They can be treated like an office. And then once you've done that, you can have smaller, more efficient central plants. So there are three options shown here. Essentially, they're using heat in a smart way, recycling it, using heat pumping technology at the core of the system. So doing that, those four things in combo, we know we can meet a really low EUI in a hospital. We were targeting 100. We showed in models that we could get there. This was a road mapping theoretical exercise. So the next thing that I ask is, can we really do this in practice? And the answer is yes. There are hospitals that are leading the way to these operational EUIs. I'm just going to show a couple really quickly. Actually, before I do, though, I forgot this was here. The fifth strategy, I always think about this after everything else, then we can apply energy generation strategies. But we don't want to do this first because we'll be buying way more photovoltaics than we need if we don't first manage the loads, reduce the energy, etc. So some precedents that are showing us the way. I'm just going to speak about these really, really quickly. They're worth diving into more. This one's called Peace Island Medical Center. This is up in the San Juan Islands in Washington State. If you haven't been there, it's a beautiful place. And this is a beautiful hospital in that beautiful place. The energy story here is multifold, but one of the big ones that I think is quite important is that it matches program type to HVAC system type. So places like operating rooms have VAV overhead mixing systems, but places that are like corridors where visitors are coming into a lobby are actually naturally ventilated and there's no mechanical cooling because we're in a really mild climate. So they're matching the program to the type of heating, cooling, ventilation systems that are necessary. It's also all electric and has a ground coupled heat pump plant as part of that. And it has been operating at about 80 kBtu per square foot year since it has been open. Another example is Harrison Medical Center. This is in design, and so we don't have an operational EUI yet, but we will soon. It was designed to meet the targeting 100 goal it says 98. That's a level of precision that's probably not real. I like to round up and say 100. And really there are a couple success stories here. One was there was quite a bit of effort to manage the load on the envelope. This is west-facing primarily facade because it overlooks the Puget Sound and the Olympic Mountains. How can you not celebrate that view? But from a mechanical systems and loads perspective, that western sun is brutal, especially in the Northwest. So we worked really carefully with the design team to craft the facade to meet lower load thresholds, which made the air handling systems smaller and actually fit in the spaces that were designed to hold them. And then mechanically at the core of the system is a heat recovery chiller that is working year round and taking all of the heating and cooling and recycling it through the system. And I think in conjunction with that, what makes this particularly efficient is a really stringent controls regime where there's lots of turn down spaces like offices that need to be turned down consistently. So with that, I'd like to transition to Travis to share his perspective, and then we'll get to Q&A.
Yeah, thanks. This is mine. That's my boss right there. Rest in peace, actually. So yeah, I'm Travis. I work for Kaiser Permanente, and Rick and Heather put a lot of technical content out there. I'm not going to repeat that. I'm going to talk really quickly and sort of high level about net zero in context. And then my job here is to queue up the conversation on COVID-19. But I'll start off, I'll say I'm very proud to work for Kaiser Permanente. This topic and this effort for us comes from our leadership. We're all about total health, health of our members, health of our staff, health of our community, and health of our planet. That was my CEO, Bernard Tyson, speaking at the 2018 Global Climate Action Summit. And he talked about the connection between climate and health and our organization's commitment to environmental responsibility. We do have a commitment to carbon neutrality in 2020, and it's 2020, so keep your eyes peeled for that announcement. And I could kind of spend 30 minutes on our projects and examples, but we're not going to do that. So I'll just sort of ask you to trust me. I've tried to put myself in the middle of this net zero conversation on hospitals for about the last decade. I will brag just for a second and say we have the first confirmed net zero clinic with a year of data to back it up. It's an 85,000 square foot facility in Santa Rosa. It's a clinic, it's not a hospital, but to the best of my knowledge, it's the first demonstrated net zero healthcare site in the good old US of A. So hit the next slide. And this is my high level. My 2020 perspective on net zero comes down to these two themes. And then in both cases, I'm schizophrenic because I hold apparently contradictory beliefs. On design, I'm schizophrenic about energy models and load calculations. I really believe that energy models are wonderful tools for design. We should use them in design at a level most people aren't comfortable with. We need to design to every hour of the profile. You can do that with computers. Heather mentioned this big discrepancy between peak and running load, and that is the truth. If you've designed for the peak, congratulations, you just designed for 1% of the year. We can and must design for 8,760 hours per year because that's how many hours there are. So I am a huge believer in design calculations and leveraging computing power into design calculations. Then, for contrast, I believe that design models are bogus pieces of fictional bullshit because they're hourly and there's no plus or minus on the supplier temperatures. They're not controlled systems. So energy performance has to be validated by the temperatures and the flows in the real building. And at Kaiser, we are all in on data-based commissioning. We put all of our chips on the trending period. One of my engineers has this saying, he says, the trend is your friend, and that which you did not trend, you cannot defend. And so we're all about that. And so then the other theme is I talk about codes, ventilation codes, which I often do. And again, I'm schizophrenic there. First, I'll tell you that most of the energy waste in hospital HVAC systems is not code-driven, it's design. We've heard design engineers, well, we could design low energy buildings if the codes didn't require all these air changes and pressures and things. That is mostly false. There hasn't been a code in 20 years for constant volume central systems in hospitals. Most of our hospitals are constant volume central reheat systems. There's never been a code that I know of that tells you to ventilate admin areas or diagnostic areas or imaging 24/7, but we do that all the time. And so for the most part, under the 80-20 rule, it is unfair to blame the codes. Most of our energy wasteful practices are in design in those HVAC systems. And then, of course, to be schizophrenic, I'll tell you that our codes are not at all credible. In the latest ASHRAE 170 document, there's a few hundred discrete room air changes and pressure requirements that are legacy requirements. I think if you Google my name and then ASHRAE 170, I'm on the record here. I've been very openly critical of that code. In ASHRAE, we know the vast majority of our ventilation requirements in healthcare have zero evidence basis, zero clinical basis, zero rational basis, zero transparency. Nobody can explain them and nobody can defend them. It's just, you know, grandpa did 6 air changes and daddy did 6 air changes, so I'm going to do 6 air changes. So those codes are a problem. Okay, so hit the next slide. And now we'll talk about COVID-19. Look, COVID-19 is not a long-range airborne transmitted disease. People in the same room with each other are the big transmission path. Everything they touch is a transmission path, hence social distancing and hand washing. So in epidemiology, there is a very low emphasis or an outright discouragement of the idea of long-range airborne transmission, i.e., the ability of COVID to move in the air, you know, from one room to the next room or down 50 feet of duct and then cause an infection on the other side of that. In the COVID wards themselves, long-range aerosols are only considered a risk during certain procedures. Those are called AGPs, aerosol generating procedures. Intubation is the biggest one. So during the actual 10 seconds that a tube goes into a throat, there is a risk of aerosolization, but that is a short duration, it's infrequent, and 80–90% of our hospitalized cases never go onto a breathing machine. So even in a COVID ward, there's very limited risk of long-range aerosols. Now, I hate to say this, but we have to say this. It is 100% in the best interests of the HVAC industry to message against this and to talk up and to emphasize the idea of airborne COVID. So most of the stuff that I see on airborne COVID is in and from the building HVAC industry. There's ASHRAE, there's consulting engineers, there's vendors, anybody on the planet who makes their living selling air purifiers or air disinfection or filters or humidifiers or HVAC controls. In other words, all of my people, we are talking about airborne COVID, and we talk about it a lot. We're obsessed with airborne COVID. We sort of talk about it every day. Go ahead and hit the next slide. Didn't I have another slide in there on the CDC? I guess not. Okay. So, but what I want to say here is that the chatter in the HVAC industry can be a source of misinformation. And there's an example that I thought I had a slide for, but I'll just tell you about it. In the May ASHRAE Journal, there was a monthly column that put out a list of recommendations, 8 recommendations for dealing with airborne COVID. It was a monthly column by an HVAC journal. It was an expert opinion piece, no experiment, no original research. One HVAC expert's opinion, peer-reviewed by some other HVAC folks. It got published, and about a week later, the CDC grabbed those recommendations from the column and put them up on their website, which is to say that now there's a CDC website that advises building owners on 8 measures to combat long-range airborne COVID, which ironically the CDC says, you know, this disease doesn't transmit by long-range. And when I say 8 measures, these are things like increase your outside air up to 100% outside air, disable all demand control ventilation. One of the ones from later on the list was to consider running your building systems 24/7. Now, as a building owner, you want to be diligent. You want to read these CDC guidelines, but these are some radical measures, and if you follow them, you could easily double the energy signature of a building. So we had to respond to it. We looked at them one by one for any evidence basis or rational basis. What benefit could we expect specific to COVID-19 spread? And of course, most of them could not be expected to yield any benefit. We actually emailed the CDC to ask if there was any additional evidence or citations, and they responded and clarified, oh, those are just recommendations to be considered. They're not requirements per se. But my message to you here is that the chatter in the HVAC industry can cause misinformation really all over the place. If I sold filters for a living, I would be sending a link to that CDC document to every building owner and contractor and consultant I know. And I know people who sell filters for a living, and that's exactly what they're doing. So go ahead and hit that last slide. I want to tell you to watch out for misinformation. Even the CDC or what you would consider to be reliable sources are not immune from misinformation. So be objective. Here are the facts that I believe to be true today. Number one, COVID-19 is of most concern in close quarters. Long-range aerosols are not the problem here. We have no reason to suspect that it can move from one room to another room or down 40 feet of ductwork and infect somebody on the other side of that. And listen, it cannot be ASHRAE that makes that claim about the nature of this disease. I am a proud 20-year ASHRAE member, but let me tell you, if you get a memo from ASHRAE that says COVID is airborne, then clutch your purse and guard your wallet because you're about to get ripped off. Number two, we don't have any evidence that increased dilution ventilation reduces transmission. And in healthcare buildings, in hospital, we already have a lot of outside air, a lot of outside air. It is very unlikely that we'll get any marginal benefit from introducing more. Thirdly, we don't have any evidence that filters or air treatment in the air handling systems are going to reduce transmission. If the COVID has to leave one room and travel through 40 feet of ductwork to get to the filter or the air treatment device, that's probably a hard no. If you want to look at a treatment within a room, that might work. You got to be very careful with that because room air is typically very slow and it's not enough velocity to move around the COVID droplet particles, which are relatively large. And then finally, there is this thread going around that relative humidity between 40 and 60% can reduce the survival of the virus, essentially. This might be the most science-based idea out there. I actually know Stephanie Taylor, I've talked to her, but again, look, be objective about this. I live in the Los Angeles area, and in March and April of 2020, our weather was 40 to 60% humidity, about 85% of the time. I don't think the big outbreak that we had in Los Angeles in April of 2020 could have been avoided or decreased by having humidifiers installed in all of our buildings. I don't think that's actually what Dr. Taylor is saying, but the messaging that's going around among humidifier manufacturers takes that message and augments it a little bit, right? So try to be objective as much as you can. To cue into the Q&A here, so how does COVID-19 relate to the net zero hospital conversation? To go back to what Rick and Heather said, under the 80-20 rule, the energy that we use in hospitals is largely HVAC. And in that area, we follow some very non-evidence-based, deeply uncredible rules on ventilation. My crystal ball says the hospital HVAC industry is not going to become more evidence-based in 2020 or in the next 5 years. It's going to get worse. I'm sort of personally committed to scrutinizing those ideas one by one as they come up. I would invite you all to join me. So it is part of our problem, and we'll just have to be cognizant of it. Let me stop there, and I think we have done well on time, and we should have tons of time for Q&A, right? So we'll turn it over to Carrie.
Yeah, thanks, Travis. And thank you, Heather and Rick. I do have a few questions as we open the floor for audience questions. So as a reminder, please continue to add your questions to the chat and Q&A feature. We did leave extra time for lots of questions and discussions. So I guess, Travis, just keeping the ball rolling on that, on the COVID-19, do you think there's anything that designers should do to respond to COVID, or are there other areas that you wish design teams would really focus on and do better to achieve more efficient hospitals?
I think the biggest questions that we've gotten on COVID, it's almost like we're focusing on the wrong thing, right? The biggest questions that we get on COVID have to do with HVAC. And I would very much tell the HVAC designers, don't change your design practices, right? If you've been following ASHRAE 62 and whatever ventilation guidelines you've been following for the last 20 years, COVID-19 is not a compelling reason to change our fundamental strategy on anything ventilation. A lot of what we dealt with within the COVID-19 crisis, oxygen distribution systems were a huge issue. So we are rethinking our design around oxygen distribution systems. In surge planning, plumbing was a big issue, right? Hand washing is a vital strategy. And so we saw surge plans for, 20 beds and one hand washing station. That's a problem. And so we should be thinking about plumbing. We should be thinking about O2. We should be thinking about, really the things that are on the front line of this disease. Obviously, social distancing, the ability to close doors, monitoring patients with cameras. We should be thinking about that stuff. Air is a red herring, right? And that's the message we've tried to hold on to as much as we can.
So with that, we had an audience question on what are your thoughts on germicidal lighting in facilities like hospitals and commercial facilities? And there's another question regarding the uptake of displacement ventilation in patient rooms due to COVID considerations. So do those methods relate, or do you think those will be successful in COVID?
So let me, I guess I'm still on point. The germicidal lighting falls into the category of disinfection, in environmental disinfection. And what we've had to, our response to the message of disinfection, obviously I get 100 emails a day with different technologies that we can use to disinfect spaces. However, we don't actually have any data to indicate that our spaces need disinfection. In fact, quite a bit the other way around. If you take surface samples from my desk here in my office, you take surface samples from, a hospital, it's cleaner. You go and take air samples from my office or from my house, and then you go and you take air samples from a hospital and look at bacterial counts or microbial counts or particle counts, it's cleaner, which is to say that hospital spaces relative to walking around outside are actually relatively clean spaces. And so the idea that, we need more disinfection, or we have a problem that requires disinfection as a solution, is one that we can't really build a business case for, right? That's not to say that those technologies don't work. Many of them have lots of data that tell you that they work, and I'm inclined to believe that data. It's just a matter of application. Can you really get some benefit from it? If you have a space that's, 99.97% clean, and you can clean it to 99.9997%, what's the benefit there, right?
So moving a little bit away from COVID specifically, but I know Heather mentioned that you can't measure you can't manage what you don't measure. And Travis also mentioned the importance of trending in monitoring a building, getting towards net zero. But can either of you talk more about kind of the performance-based tracking and auditing that you do for hospitals and what has been successful in getting closer to being able to be net zero?
I can start with that and then let Travis talk about their efforts, because I know they're doing that too. I think it kind of goes back to that same mantra of, with existing facilities, there's always opportunity for energy saving. And I don't know it just depends on the existing facility if there's really opportunity to get it to net zero. But there is always opportunity for energy savings. And so, our approach has been there isn't a one size fits all, knowing the facility, going in and being able to see how things are being operated, and being able to continuously improve has made a big difference. And some of that is cultural. I'd say probably a lot of it is cultural. We have technical solutions to be able to reduce energy, but being able to have a culture of efficiency or conservation as part of the culture is a really important thing to embed, but really, really difficult. And we find that facilities engineering staff are often, they feel really thin on how much time they have and don't have a lot of time, on what ends up being the side of their plate to think about efficiency. So, when we come in as a consultant to those kinds of situations to help a hospital meet a certain energy goal, it's technical in nature. It's about what's actually happening at that facility, but it's also cultural about how can we shift the mantra of what the priority is, not shift it away from patient care, safety, comfort, but an example is, if there's a cold call and the control system is changed, sometimes that change persists for years and years and years, and nobody sees that the change has been made. And that makes a huge energy implication. And so if the culture is we're going to change it the second we get a call, that may be problematic. And if the culture is we don't ever go back and look to do quality control to get us back to where we were meant to be, that can be a problem. So that's one way to address that question. I'm sure Travis has some thoughts too.
I do, and I know that. So, Carrie, I know you're a commissioning agent, and I think Rick and I both come from the design world. So the story that I've told before is that I practiced design engineering for a decade and change as a consulting engineer. And I can't count on one hand. I mean, it was less than 5 times that I actually went into the building data and checked the heating loads, in the peak of winter, or checked the cooling loads in the peak of summer, let alone the most important thing that I should be checking is how much energy is the cooling system using at 4 o'clock in the morning when it's 68 degrees outside. It should be using nothing, right? And did I actually check that? Did I actually validate that? Did I validate the temperatures and the flows and the delta T's? As a design community in the United States, I think it's very fair to say that 99.5% of the designs that we put out in the world never get validated. And that is cultural. The technology is there. We're doing database commissioning. We're requiring monitoring-based commissioning. We have 200 of our buildings plugged into a monitoring-based commissioning dashboard and diagnostic system. I can look at 5-minute interval data of delta T in just about every system in 200 buildings. And the truth of what happens in those buildings, I say it's like getting really drunk and depressed and looking at yourself in the mirror naked. Compared to the design assumptions that we make, the truth of how mechanical systems really work is really, quite shocking. And so we need to design differently. And part of designing differently has to be a continuous just practice of validating all those design assumptions on every job. And so in the last 3 years, we have pushed that. And I'll tell you, our design engineers are not comfortable with it. They hate that conversation every time we have it. And our commissioning agents too. They're a lot of them hate it.
So getting into a specific example, there's a question about what impact do negative pressure rooms have on energy usage? And would the increase in adaptability of existing rooms to negative pressure rooms have an impact on the energy usage?
If you want me to start on that, maybe.
Hey, Travis, I love that this audience is getting to hear from you directly. So I'm just sort of being quiet because we've talked about a lot of these things and are in alignment.
Listen, negative pressure, first off, again, COVID-19 is not an airborne transmitted disease. Unless you have an aerosol generating procedure, negative pressure is really a red herring. It's a psychological measure. We've done, Kaiser Permanente probably spent $10 million on negative pressure conversions in the last 100 days. Mostly on a psychological basis. It doesn't actually do anything. That being said, there are certainly ways to do negative pressure without a major contribution to energy signature, where I would anticipate you don't even see it on the bills. Most of the energy that we use in healthcare systems is not in the critical spaces. The single most common space in a hospital is a corridor. Right? We have I think the stat is we have 1/3 of a mile of corridors for every 100,000 square foot of hospital. And so if you're ventilating those corridors with 6 air changes per hour, 24/7, there's absolutely nothing you could do with the isolation rooms that will ever hold a candle to your strategy in the corridors in terms of the monthly bills that you actually get at the facilities. So I'm of the opinion we treat critical spaces, ORs and isolation rooms, we treat those like critical spaces. We do the absolute best that we can. Where we're wasting energy is the corridors and the offices and those general spaces. Stop wasting energy there, and then we'll get to those ORs and isolation rooms in 10 years when we've gotten rid of all the rest of the waste.
So on that, I guess on utility usage also, what are your recommendations for moving facilities away from natural gas? Audience question, we see barriers with sterilization, humidifications, and in some cases peak heating.
Yeah, so I was getting ready to, I actually was going to answer that in the chat, so I'm glad you brought it up. So I saw that question. So sterilization, we are commonly deploying electric solutions for sterilization, and there's lots of alternatives to sterilization that are low energy consuming. So natural gas is not needed for sterilization, in our opinion, in hospitals. Humidification also, there's a lot of alternative technologies that do not consume a lot of energy. And the natural gas humidification solutions, we're going away from centralized in a lot of cases. Basically, we're just going away from centralized steam, because the cycle losses that Travis was alluding to there in the boiler plant, if you actually measure how much energy those steam plants are consuming, you'd be amazed. So when you go to electric solutions as the energy source, you can actually dial in how much energy you're consuming, and you don't have all those cycle losses. So it consumes significantly less energy, and there are some alternative technologies. And then she mentions, or something that here mentions, peak heating. For that, I think, and Travis and Heather's research supports this. You got to look at that 8760, and you're not in peak, but 1% of the time. And so even if your coefficient of performance in peak heating was 1, for every 1 watt, you're getting 1 watt out for peak. If you've maximized heat recovery and energy recovery in your central plant, where you're making chilled water and hot water at the same time, and your coefficient of performances are as high as 4 or 5, you're ultimately saving energy. So those are the types of technologies we're looking to deploy.
Great. Another kind of technical question. I'm skipping around here, but are there barriers to adding natural ventilation to healthcare spaces like lobbies, waiting areas, circulations? Is that a possible solution to not using so much energies in these corridors?
Yeah, I'll take that one. And we see precedents that do that. So there may be perceived barriers, and there may be some AHJ conversations, but we see openable windows and natural ventilation, in fact, in patient rooms. So then outside of those spaces, in offices and corridors, yes, you can do that. The inpatient rooms question, that Peace Island hospital example I showed has operable windows in the patient rooms. Those are not tied into the HVAC system there. However, there are examples that are. And so when the window is opened, the return air through the toilet room is still on. And so the fresh air from outside is serving the ventilation needs and meets code. So we definitely we see that. It's not as prevalent. But I want to also connect that to another question that came up about displacement ventilation. We skipped over that. I will say, in my experience in the last month even, in some early design thinking for some new hospitals, these are strategies that we've talked about for a long time. We know they save energy. They're also have a lot of what I deem as non-energy benefits that can provide more comfort, more connection to nature, for example, with the operable window, more home-like atmosphere in a, what otherwise could feel pretty sterile. But the conversation that's coming up in the last month is we also see that there's some resilience in those strategies and more willingness to think about those strategies in that way. So, with displacement, it's 100% outside air system. It's delivering the air in a different way. The CFD models show that it evacuates the air in a way that disturbs particulate matter less. Those things are mattering more right now, which to me is exciting because I think we should be doing those things. And there's maybe more reason in our minds now to do them, where, gosh, if we say, and I don't know how this relates to Travis's conversation about COVID not being airborne, but we see lots of recommendations about just open the windows, like keep your space ventilated. And if that's the case, let's have windows that open. And I hear hospital facilities that have otherwise been pretty resistant to that idea, saying, well, we at least want to have that as an option. So to me, that's exciting. I'm seeing a shift in the conversation around those things.
I do want to be clear that right now, National Standard ASHRAE 170 does not allow natural ventilation. So anytime anybody's doing it, it's a variance. I've been petitioning that group for, I think, about 5 years to try to get it allowed. And
Travis,
there's
that's
no
in patient rooms, right? Not in the corridor, not in corridors or public spaces.
No, it would be prohibited in corridors. Public spaces, non-healthcare spaces. So if you had just a lobby or a coffee shop or an office, then it's allowed, right?
Yeah.
But any space that's covered by those, then, and again, that's the national standard is the code basis. You can get a variance, obviously.
Yeah.
And that's totally been done. We have petitioned them. They have that proposal. They may even have version 2 of that proposal. And so hopefully at some point in the next, generation, our national standard will allow it.
Great. So shifting over, there's a questions on PV systems. So there's the question is, there's conflicting data on how good the photovoltaics are, how green they really are, what they contain, and how they're disposed of. Do you guys have comments on how that achieving net zero also helps us, or if we can be conscious of the environment as we do that?
Yeah, I think this brings up, I'm just going to bring up the larger question here is, we've been focusing on energy, but high performance buildings encompass much more than just energy. They were starting to think a lot more about the materials that are in our buildings, and PV, I would lump PV into that category as a material. And not only their embodied carbon, but also their material toxicity and then the whole life cycle of a building from extraction to grave, right? So I think it depends what lens of analysis you're looking at, whether and PVs and or anything that goes in the building, how environmentally friendly it is. And that for the PV question, from my perspective, that's another point of energy efficiency should always be the first strategy, right? That's not something we're putting into the building. It's something we're taking away. And so to me, that should be the first thing that we do. And then if we think that we need to get further, then we would apply a material to help us get there. And I personally can't speak to the nature of the toxic materials in photovoltaics. I'm sure that they exist. So I'll leave my comment to that.
We have a lot of questions getting back to COVID and current conditions. One question is, do you see hospitals reconsidering department adjacencies in the future to keep immune-compromised patients safer in hospitals during another pandemic, and to streamline how energy serves occupied areas of the hospital to reduce energy consumption and power demand during a pandemic? And maybe this is a bigger question also on how could this pandemic change design considerations in the future, or how should it?
I'm going to start on that, and I'm sure Travis and Rick have opinions, but another kind of zooming out answer is, I think it's going to be it's really important as of February this year and of June this year to think about programming in a really smart way. Like, how are we programming the hospital? And we can think of energy as a part of the programming exercise and grouping things in a smart way. But in the small conversations I've had recently about hospital design, we're thinking about there may be different nature of waiting areas, different nature of nurse station and exit and entry, things like that. But I think if I'm on the design team, I think about, like, how do we group these things together in a way that makes sense for medical planning, but also makes sense for energy?
I think there's no question that that the COVID era is going to have an impact on our design standards. It's really just a matter of making sure that those are thoughtful changes and how we're going to do it. The biggest thing that I learned is actually a kind of if you type the word ventilated headboard into Google, and you'll see this solution that actually the CDC came up with, which is a non-infrastructure solution. So rather than, I know we're going to have a code conversation over the next 10 years about, we should increase the number of airborne isolation rooms. I think that's not the answer. I think the answer is flexibility. And these ventilated headboards can be built on site. I sent a sketch of it out to one of our field teams, and they sent me the picture of the thing about 3 hours later. And so the idea to have quickly deployable, very local solutions is important. I know that in the planning community that I actually work for, our planning group, there's a lot of conversations now around that flexibility. Exam rooms, we've published some stuff about how to make exam rooms flexible for different types of cases. And then also the whole idea of a patient room door being open versus door being closed. There's obviously video monitoring techniques that are going to come into play. The regulatory rules around that are going to change. But also on the clinical side, virtual visits. I think the last 10 years, doctors have been telling us we can't do virtual visits. We need to see every patient. And that myth kind of got busted in the beginning of this year. And so you are going to see some pretty radical changes, to our overall approach, I'm sure.
Yeah, and regarding
my only comment to add, just since we're running out of time, is the takeaway of so much of design is for these shoulder cases. There's 8,760 hours in a year. So much of design is for that 1% occurrence, and this could be another, external force that creates a shoulder case. And as a designer, what I'm going to work really hard to do myself and challenge our teams is to really consider or apply first principles. And as we're addressing these shoulder cases, we're not doing so and taking away the flexibility to really optimize performance for what's normal. Like nothing's been normal the last three or 4 months. So, but eventually, at some point in the future, we'll get back to normal, and our buildings have to be able to be optimized over as many hours as possible of those 8760. So I think that's the biggest thing to take away. Travis mentioned it and beat it into me when I was talking to him. That's what I'd share with the group.
I think also that leads into like just a general thinking about resilience, like maybe we're not thinking just about COVID, but like thinking about like in these cases, how can we design something that's flexible enough that can work with something we don't know what it's going to be, And so like trying to make our hospitals and buildings more resilient over time, I think is really important.
So we have time, I think, for one quick question, but what do you guys think prevents design teams from achieving and realizing their energy goals?
I think I saw the question.
Go out there and measure them.
Yeah. I think we don't know. I mean, we don't think about energy. We don't know what it is. It's this thing that we can't grasp in our hands. And then I think there's a lot of design that's happening in tradition. This is how we do it. This is how we've always done it. The code allows it. So that's the way it goes. And then I think if there is thinking beyond that, then there's a perceived risk, and that could be a perceived risk in these systems aren't going to work, or a perceived risk in this is going to cost a ton more. And so a backing away of, we don't want to go there. And I think what we know is that's not true, but I think it gets out of a comfort zone for, big middle market for sure.
I hate to interrupt this really interesting and exciting conversation and exchange, but we come to the end of our webinar. I want to thank again our panelists and our moderator, Carrie, Rick, Travis, Heather. An amazing presentation, a really engaging discussion. We appreciate it. And thank you to all our participants for your active engagement and for the questions we received. Just a couple of notes. Our presentation was recorded and it can be accessed on the Members Resource Library on Women in Healthcare website. And also, if you have questions that we were not able to answer, if you have additional questions, please feel free to email those to info@womeninhealthcare.org, and we can get the answers to you through our panelists. Thank you again very much, everybody, and have a good rest of the day.
Thank you, Stella. Thank you, Heather, Travis. Thank you, guys. See ya.
Thank you all. Thanks for attending.